Now you are going to learn a new concept called kinetic interpretation of temperature. Here you are going to learn the temperature in terms of kinetic energy of gas molecules. That's why the title is given like this. How to start the derivation, the expression of the kinetic energy that should be given in terms of temperature. So already while deriving the pressure of the gas, already you have derived the equation P is equal to 1 by 3 N by V M V square bar. So clear, this equation was already derived in the previous class. Here this V square bar is called as mean square speed. This is called as mean square speed of the gas molecules. Are you clear? Here N by V, that is called as number density. This factor is called number density. Number density means within the given volume how many number of gas molecule or air molecules are present. That factor gives you basically the term called what is as number density. So this entire factor that gives the pressure of the gas. Already this equation was already derived in the previous class. Just you cross multiply this. PV is equal to V to be cross multiplied 1 by 3. After cross multiplying, the remaining factor is N M V square bar you will get. Are you clear? Here we know the ideal gas equation, that is PV is equal to NKT. NKT. Often we are using this expression. Are you clear? This is called ideal gas equation. In this equation, PV is equal to NKT. No, this PV can be replaced by NKT. So NKT, you know what are K? K is called Boltzmann's constant. NKT, T is nothing but absolute temperature. So 1 by 3 N M V square bar. Appropriate notations must be written, only then there won't be any error. N can be cancelled, and then cross multiply this 3 here, you will get 3 kT is equal to mv square bar you will get. On either side multiply the factor by 2. So here divide the factor by 2. Are you clear? Divide the factor by 2. Why the both the two factors to be divided by 2? Only then you will get kinetic energy. Are you clear? On the other side you will get half mv square bar. No, that's why. So 3 by 2 kT is equal to 1 by 2 mv square bar you will get. Are you clear? Now we can write this factor clear in this side. So what is half mv square bar? That is nothing but average kinetic energy per molecule. Are you clear? This is nothing but average kinetic energy per molecule. I will write it here. Half mv square bar is called as, that is nothing but average kinetic energy per molecule. This is nothing but this half mv square bar is called average kinetic energy per molecule. That is equal to which one? 3 by 2 kT. Very important equation. Throughout the lesson, clear, this expression will be often used, and you also must by heart this expression 3 by 2 kT. Are you clear? This is the value of clear average kinetic energy per molecule. Each molecule, clear, on an average they possess this much amount of kinetic energy. Are you clear? So the average kinetic energy per molecule that purely depend on the temperature of the gas. That's why the title is mentioned here as kinetic interpretation of the temperature. Here the temperature that indirectly is clear, it measures the kinetic energy. The kinetic energy of the molecule per molecule that purely depend on which factor? Temperature. If temperature is more, kinetic energy will also be more. Are you clear? We are not able to see the movement of the molecules, but we are able to measure the temperature of any gas. Are you clear? If temperature is very high means it shows that kinetic energy per molecule is also very high. So kinetic energy, average kinetic energy per molecule, that purely depends on the temperature. That interpretation must be clearly known. Temperature is the measure of average kinetic energy per molecule of the gas. That is the important key point. Are you clear? Temperature. In lower class level, so many definitions you have learned. Now you are learning a new definition. Temperature is the measure of nuclear. You are measuring temperature means what indirectly it measures. Temperature is the measure of average kinetic energy per molecule. If average kinetic energy per molecule is more, it shows that temperature is also more. Okay. Now we are going to derive the most important expression called, what is this? Internal energy. Already in heat and thermodynamics lesson, you may have learnt about the term called internal energy. Internal energy is possessed by the system. If you sum up the kinetic energy and potential energy of the molecules, that one gives you the internal energy. That is mentioned by the letter U. Are you clear? So far we have not used any expression to calculate the internal energy. This is the first time we are going to derive the expression for internal energy. How to calculate internal energy? Very simple one. Are you clear? Internal energy of the gaseous system of ideal gas. How it can be calculated? We have to count totally how many number of molecules are available. That is nothing but N. So clear, if you have to imagine that in a container, this many number of molecules are there. The total number of molecules is called as, what is this? N. Are you clear? Total number of gas molecules. And it can be written as total number of gas molecules. That is nothing but N. That must be multiplied with which one? Average kinetic energy of each molecule. Are you clear? N into, just few minutes back we have derived the expression for average kinetic energy of each molecule. What is the formula? 3 by 2 kT. 3 by 2 kT is the expression to calculate the average kinetic energy of each molecule. Now you combine this. 3 by 2 N kT is the expression. So this is the expression to calculate the internal energy of any gas. Are you clear? Here also the internal energy that depends on the temperature. If temperature is more, internal energy of the system will also be more. Here number of molecules is clear, is constant, and K is also constant. 3 by 2 is a mere number. Therefore internal energy that purely depends on which one? Temperature. Are you clear? If you observe that if the temperature of the system is more, means it shows that the system is possessing large amount of internal energy. If the temperature is low, means the internal energy of the system will also be low. So internal energy is also a measure of which one? Temperature. Or temperature is also the measure of internal energy. So both can be measured, is it clear, in a parallel form. Are you clear? So very important formula. So far we have not seen, we have not used this internal energy. By using this, one problem is given, I will work it out, that problem separately. Okay, thank you.